Good morning to all. Today we are going to discuss about fundamental frequency and overtones. At the same time, already we have discussed about standing waves in sonometer string. I am correct or not? Take and see in your textbook, because otherwise you cannot understand about today's topic. Okay, come and see. I think page number 256. Okay, come and see first to bottom. Okay, fully this page number fully, because otherwise you cannot understand about fundamental frequency and overtones. Okay, come on, fully, quick, clear? Okay, now we are going to discuss about fundamental frequency and overtones. Listen. Fundamental frequency and overtones. Okay. Already we have discussed about standing waves, no? Yeah. How do you produce standing waves? Just flicking by the string. That means on the center of the string. For example, in guitar, you can produce standing waves. Am I correct? Yeah. How, sir? Listen. Like this. Okay? Yeah, like this. So these points are called nodes. What? Nodes. Okay? These points are called nodes. At the same time, this gap, these points are called antinodes. This is about standing waves. N represents nodes. This is antinodes. Okay? Yeah. Then, at the same time here, what is this? One full wave, no? Yeah, one full wave. Length of one complete wave, that is called wavelength. Yeah, this gap, this is called wavelength. It is simply represented by lambda. Okay, what will be this gap? Yeah, very good. It is equal to lambda by 2. Okay, that means the distance between successive nodes is equal to half of the lambda, no? Yeah, it is equal to lambda by 2. Okay, so lambda by 2. In terms of n, lambda n by 2. Lambda n means here specific wavelength. Okay, or in terms of n lambda n by 2 is equal to n. Okay, sir. Here, what is meant by n? Integer. N means integer. 2 means okay number. L means here distance between two boundaries. Distance between two boundaries. Okay. At the same time, what is meant by lambda n? Specific wavelength. Okay. So from this formula, lambda n is equal to, we can written as 2L by n. 2L by N. Okay. Okay. Lambda N is equal to 2L by N. Clear? Yeah. Then here, what is meant by N? Integer. If N is equal to 1, if N is equal to 1, lambda 1 is equal to 2L by 1, no? Substitute in this formula. As N is equal to 1. So now we get 2L by 1. It is equal to 2L. Okay? Yeah. This is first mode of vibration. What? First mode of vibration as specific wavelength lambda 1 is equal to 2L. Then if N is equal to 2, yeah, substitute in this formula. Lambda 2 is equal to 2L by 2, no? Yeah, 2 to cancel, no? So lambda 2 is equal to L. This is called second mode of vibration has specific wavelength lambda 2 is equal to L. L means distance between two boundaries. Okay. Then if N is equal to 3, lambda 3 is equal to, substitute in this formula, 2L by 3. Okay. This is third mode of vibration as specific wavelength lambda 3 is equal to 2L by 3. Clear? Yeah. And so on. So the frequencies. What? Frequencies. Here L1, L2, L3 wavelength. That means a specific wavelength. But frequency of each mode of vibration. What? Frequency of each mode of vibration can be calculated further. That is called a natural frequency. What? Natural frequency. Okay? Listen. What is the basic formula? V is equal to F lambda, no? Yeah, F means the frequency. Okay? So, F is equal to V by lambda. Okay? Or in terms of N, N means integer, no? Therefore, F suffix N is equal to V by lambda. Okay? In terms already calculated lambda N value in this box. I am correct or not? Yeah, directly substitute in this formula. Now we get Fn is equal to V by 2L by N. I am correct or not? N means integer, no? Yeah. Or goes upside. I am correct or not? Yeah. Vn by 2L. Okay. Or N of V by 2L is equal to F. Okay, that's all. Clear? Next we are going to discuss about overtones. Okay, with the help of frequency. Okay, listen. If N is equal to 1, again, N means integer, no? Yeah, if N is equal to 1, this is the basic formula. Okay, if N is equal to 1, substitute here, F1 is equal to 1 of V by 2L. Okay, that means F1 is equal to V by 2L. This is the value for F1. Here F1 means a fundamental frequency. That means a basic in standing waves on a string. Okay, so F1 is equal to V by 2L. Okay. Already we have studied about Here V means, yeah, velocity of transverse wave in a string. Okay, that means in a stretched string, that is important. Okay, what is the formula? Already you have studied about this, no? Yeah. Come on, tell me. Root of, that is wrong. Yourself. Root of T by, very good. T by mu, correct, you are correct. That is the velocity of transverse wave in a stretched string. Already discussed about this, okay? Yeah. Keep in your mind, this is very, very important formula. Use it for solving the problems, new theory or NEET examination, okay? Yeah. Root of T by U, mu. What is meant by T? Yeah, tension produced in the string. Mu, mass per unit length of the string. Tension of the string, mass per unit length. Okay. Tension in the string, mass per unit length of the string. Okay, yeah, very simple. Now substitute in this formula. F1 is equal to 1 by 2L of V, no, therefore root of T by U. Okay, so here F1 means fundamental frequency, right? Then if N is equal to 2, this is the basic formula, no? Yeah. So F2 is equal to 2 of V by 2L, no? Okay. 2 to cancel. What is the remaining? V by L. Okay. And you can write as 1 by L of V, no? Yeah. So 1 by L. V value, very good. Root of T by mu. This is F2. So F2 is equal to, you can written as 2 F1, no? Yeah, 2 comes down. V by 2L is equal to F1, no? Yeah, so F2 is equal to 2F1. This is first overtone in Tamil, Mersuram. Mersuram. This is basic. This is basic fundamental frequency F1 V by 2L. This is another frequency, no? F2. So this is basic. Mersuram overtone. So this is first overtone. F2 is equal to 2F1. That is called the first overtone. Mersuram, Mer Porundadal in Tamil. First overtone. So this is called first overtone. Okay. F2 is equal to 2F1. Or we have another name also. Yeah, wait. I will tell you later. Not now. Okay. Then, if N is equal to 3, N is equal to 3. Yeah, substitute this formula. F3 is equal to 3 V by 2L. I am right or not? Okay. Or F3 is equal to 3 1 by 2L into V, no? Yeah, V is equal to, already written here. Okay, so F3 is equal to 3 into 1 by 2L of root of T by U. Okay. Or F3 is equal to 3 V by 2L, no? F1, okay? Yeah, so F3 is equal to 3 F1. This is second overtone. Second overtone. That's all. And so on continuously. F4 is equal to 4F1. At the same time, here natural frequencies are written. Basic formula, Fn is equal to n Fn, no? Yes. Fn is equal to n Fn. You can write like this. F1 is equal to 1 F1. So F1 is equal to F1. That's all. F1 is equal to F1. Substitute n here. F2. Here n. So F2 is equal to F1, no? Where? Yeah. F2 is equal to F1. I am correct or not? Very good. F2 is equal to 2F1. Okay? 2, okay. V by 2 is equal to F1, no? So 2F1. That's all at the same time. F3 is equal to 3F1. Okay. So natural frequencies are written as basic or fundamental frequency. That means natural frequencies are written or basic frequencies are written as integral multiples of fundamental frequency. So generally keep in your mind, natural frequencies are written as integral multiple of fundamental frequency. So Fn is equal to n F. That is called harmonic. What? Not overtone, harmonic. So what will be name of this? Very good. First harmonic, fundamental frequency. Second harmonic, but first overtone. Very good. Third harmonic, but second overtone. Clear? Very simple to read this. Shall you go to next one? Yeah. Listen properly without seeing others. Next we are going to discuss about laws of transverse waves in a stretched string. We have 3 laws. How many laws are there? 3 laws. Listen properly one by one. Simplest and very percentage important topic this. Okay, come on. First one, law of length. Okay, listen. Law of length. Okay. So according to law of length, we can written as F proportional to 1 by L. Okay, this is frequency, vibrating length. Okay, this is number. Which components or symbols absent here in sonometer or velocity of the transverse waves in a stretched string? What? Very good. T and mu absent. Okay. So absent means here taken as fixed. Taking as fixed. Okay. So if tension produced in the string, mass per unit length, I am correct or not? Fixed. So come on, tell me the law with the help of this simple formula. Yeah, frequency varies, or generally frequency is inversely proportional to, okay? Frequency is inversely proportional to vibrating length. That's all. First you write this symbol or formula only, then you can write a statement very simply with the help of this symbol. That's all. But you must know about what is meant by F, what is meant by L, what is meant by T, what is meant by U. That is important. Tension produced in the string, no? Yeah. Mass per unit length, no? That's all. So frequency is inversely proportional to vibrating length. Okay. So when we cancel this symbol, we must add one constant, no? Yeah. Here C is constant. So C is equal to FL is equal to constant. Okay. Very simple. This is about a law of length. Okay. Then keep in your mind while writing 3 laws in this topic like LTM, like ATM. Keep in mind LTM, that is important because of you can write orderly. with the help of the symbol LTM. L means length, T means tension, M means mass. That's all. So law of length finished, completed. Then very good. Law of tension. Very good. Law of tension. Very good. You're talking about tension now? Yeah. T. Then F proportional to root T. According to law of tension, F proportional to root T. Which symbols absent here? L absent. Yeah, very good. Mu absent. So that means fixed, constant. Don't disturb that. That is the meaning. L comma mu fixed. When L comma mu fixed, frequency is directly proportional to square root of tension produced in the string. That's all. When we cancel this symbol, yeah, you must add on constant. No, here A is the constant. Or A is equal to F by root T. So here A is equal to constant. That's all. Clear? Yeah. Next, L T M. No, last one. M means mass. So law of mass. That's all. Law of mass. Okay. So according to law of mass, frequency proportional to 1 by root mu. That's all. What is the meaning of this? Which symbols absent here? T and very good. L. T and L. So tension and unit mass per unit length in a string fixed. Tension produced in the string and mass per unit length in the string fixed. L means here not mass per unit length. This is vibrating length. Tension produced, for the disturbance. T is the tension produced in the string. L is the vibrating length is fixed. Here mu is the mass per unit length. Okay, right, already written in the board. Okay, yeah. So frequency is inversely proportional to square root of mass per unit length when tension and vibrating length is fixed. That's all. So F is equal to, here when we cancel the symbol, we must add on constant. No, yeah, B by root of mu. So here B is equal to F into root of mu. So here B is equal to constant. Clear? See 1 by 1. F proportional to 1 by L. F is proportional to root of T. F proportional to 1 by root of mu. That's all. Here T mu fixed tension and mass per unit length. Vibrating length and mass per unit length fixed. Here tension and vibrating length fixed. That's all. Clear? Any doubt? No doubt. Thank you.